So hey everyone, this might be my first recorded video of this contest. I'm going to post videos of every contest which I'm going to participate in on Code Forces as well as CodeChef. I will try my best to explain the solution which I'm writing, but while I'm writing the solution, I might not be able to explain you. So sorry for that. You can watch these videos for to know the solutions of the problems after the contest. This these these videos are not going to be from the these are not going to be live stream. An array A of length n is a good if the sum of all elements is non-negative, that is non-negative integer x such that if you add x to each element of the array, the array becomes good. That is an array B of defined as. So okay, the question is just straightforward. We can just add the elements. I like my code to be formatted, so we just check. Mm, mm, so, we will take just the seal. I feel so, and this should work, I think. Start again. What is wrong with my laptop? You start with an integer x equals to 0. For n turns, you do exactly one of the following. Either you add 1 to x or you add 3 to x. Okay. For example, okay, so given an integer and print whether it is possible that the final value of x is m or not. Okay, we are just adding the odd values. Okay, we can increase it by 1, so every value will be possible, I think. It will not be possible. Second. Okay, you have to add n times exactly, so that's what they're asking. So if we do not add, if we add 1 in the place of 3, what will happen? It will change our answer by 2. Okay, so so 3 and minus x should be even and x should be okay. I like int m c in equals to n if m is less than n or m is greater than 3n, we can directly output no. Okay, we just or 3n minus m modulo 2 if this is odd. So we have to just output no. In other cases we have to output yes. So I think you might be yes, no, yes, 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 no, yes, no, no, yes, no, submit. So chef has a strictly increasing sequence A of length and that he wants to convert into an arithmetic progression. In one operation, chef can choose some integer and then insert it anywhere into the array. The minimum operation required for chef to achieve his goal. It can be proved that it is possible under the constraint of this problem. Okay, so the array is increasing, so whatever the first element is, we have to insert values so that it becomes a arithmetic progression. But how? The main thing is here is to find the difference, I think, because while building an arithmetic operation, arithmetic what do we say, progression, we need difference which will be added to the initial element and then the elements which are coming one after another to get the upcoming elements. So I just think this might be of an binary search and it is asking me to minimize find the minimum operation required to chef to achieve his goal. Proven it is possible under the constraint of this problem. Okay, so we have to insert some elements so that it becomes an arithmetic progression. It might not be possible, I think, but it is written that it will be possible, so I think okay. The higher the d will be, lesser the number of elements will be in the arithmetic progression, I think. So I think this is a reverse question. We have to apply binary search on d and we have to find the maximum d which is possible for this question so that the array become arithmetic progression. And each consecutive element uh, should be divisible by d. So okay, I got it. So let's just write the check function. So check function d for d we will check. So we got a d. So now we have to check whether it is possible or not to get it. Firstly, I should do a proper so that it become properly. I don't like for each consecutive. So for each consecutive this it should be for int, and what will be the number of, okay, should be infinite first. Okay, if it will be possible then we will, okay, number of ops 0, 1 I less than I plus plus, if I minus a I minus 1, it is increasing, yeah, it is increasing, modulo d is something, then return false. Else we will just add this into ops, d can be 0. Okay, so if d is 0, then all the elements should be equal. Okay, now we just write here. And if this is true, then answer will be equals to 0. Yeah, and return true. Okay, so here we will just write a minus 1 a minus 1 divided by d. So if the difference is just d, it will output 1. So it will say that it requires one operation, which is not, so we have to minus 1. So after getting the ops, we will just do answer equals to min of answer dot ops, and okay, after seeing the constraints, and also one thing that it is not a linear function, that this is my mistake. So if the constraints are this loose, we can just have we don't need return and all, return false, return true, we don't need, we just need the updation of the answer, and that is we are doing. So what we can just do that we can check for each d this. So what will be our each d? For int j equals to 1, j less than n, j plus plus, and so for each of this d will be int d equals to this element minus the previous element, and this should result in the best answer. This might result in the best answer, but I don't know. We can take the GCD also. Yeah, I think the GCD will be the answer. Just use this first. But my intuition says that If we take just the GCD and check how many operation it will take, then we will just get the answer. I was not declared. Okay, this should be J. It is outputting 0. We are taking N, we are taking A, and oh, we are returning here. We should break here. Okay, okay. A blunder, huge blunder. Okay, we can just return, and here we should write that for int j equals to 1, j less than n, j plus plus. We'll just call no check for a j minus a j minus 1, and here we can just output the answer. That should work. This is working, but I think this solution is wrong. Because we should take the GCD of these. I can submit it, but because there is no loss on CodeChef, but this will output the wrong solution. Because it is not necessary that difference between two consecutive elements will be the best difference we can get for this solution. There will be cases where the difference between one element is 2 and between another element is 3, and to get the best answer will be 1. So yeah, I knew that. So the difference, we have to just take the GCD of these differences and int g equals to 0, and we can just do this. G equals to GCD of g comma a j minus a j minus 1, and this will result in a solution. Submit. I'm pretty confident about this. Yeah, I knew that. It was quite intuitive. You are given two integer n and m and two array a and b. Define fx as follows. Start with y equals to x. Okay. Two integer n and m. Okay, what is y and x? Okay. Let's read this first. Start with y equals to x for each I equals to 1, 2, 3 to n. In this order, update y equals to y equals to max of y plus vi ai, and fx is the final value of y. Okay. So it is just that find Okay, for each. So if we look here, these values, okay, what will it change? The value of initial y and the final value. Okay, initial value. How the initial value will change this? Okay. At each point, we can have, okay, two things. Mm. At each point, we will assign AI or not will be decided with the initial value of x. This is my first observation. That if the value of the summations after adding bi, like the maximum value which we can get. What's wrong with this? We have to take care of a lot of values. What are the constraints? B is till 10 to the power 4. This is hinting somewhere. I feel so. No, it is not. We cannot do this in that much complexity. The main thing is that whether the y will be updated with this value or this value. So we have to keep the track of these two. But yeah, like for each index there will be a y such that like there will be a y such that it will be updated with b uh, above that y, and it will be updated by a below that y. So x and y only can be, yeah, x will be only positive because we are taking it 1 to m. So wherever bi is greater than ai, it is obvious that it will be updated with this. But if ai is much greater than the, okay, for each index if we just keep the record of which value we should have for each. Okay, we have to just output the summation of these values. I was thinking of outputting, okay, so it makes the question quite easier. Um, okay, so for each bi, the value of y will be depend on ai before it, or the value by which this vi is getting updated with this. So I'm not getting. What can we do? My internet is working. Sudo code first, then code with ease. Yeah, that's not true for me actually. So what we can do in this question? So we have to just add bi to the maximum y we are getting from the previous index. But it will depend on the initial x. And initial x can be anything. Oh, anything, not anything, but this. There will be some initial x for which it will output this. If we find that, but still the previous values will be, for each previous value, if we find that, but it will be very costly because checking this is not an easy job. Can we use prefix sum here? We can use it, but we don't need to actually. Okay, we need to actually. I don't know. So if you noticed or not, but in CodeChef the problems get shuffled in the order of like not shuffled actually, get ordered in the decreasing of the accepted submissions. So yeah, it is still there. So it is easier than this range max. But I think I will be able to do the max one. Maybe. Let's read this first. Insert x into array in array position. Choose an array such that let x be max of this. Insert x in the array position. Okay. Given the integer k, find the minimum position needed to insert k into the array. Note that you need to do even if the array already contains k. Okay, we have to insert k, so we need 0 to k minus 1 element in a range. This is okay, they're asking the minimum moves. We have to just find the range which have maximum, which has elements which are less than this or just greater than this. We can just add the elements which are not in that and less than this, and it will give us the answer. The main problem is that if this integer is already there, the max will not be equal to this, so we have to just avoid this integer. The main thing is that, I think so. We have to just avoid this integer, and we have to find okay, we have to just divide the array in the ranges uh, of this element, and we have to just check like how many elements are less than this. If the number of element is very if the number of element is just equal to this, we have to subtract the number of element from this value and add 1, and it will be the answer. Okay, so let's do that. We had int n comma k sim k. Or we can just int find, a function which takes the integer in this range and the k, and it finds the unique number of integer below this. So we can just do one thing. We can just have a bool vector it will be count of n k initially for int in I equals to a if I is less than k, cnt I equals to true. Okay, so for the number of elements, okay, for int I equals to 0 to I less than k I plus plus, so if cnt I, then num plus plus, and we have to just return the num minus k plus 1. If okay, we have to first take the x c x. Okay, if x equals to k, we can choose an empty range. No, our range cannot be empty. So what we can do if temp dot, if not temp dot empty, so maximum number of operations will be required will be, I think it will be k. Find a comma k, else we will just push these element into x. So one more thing, we have to clear it, temp dot clear. Okay, see out, maybe this will work. Okay, it was not declared. Oh, temp, that should be temp. Why is it outputting this? Okay. So we can just use the whole range as well in the end. So I have to do this. Time will not. Okay. We should. This will work, I think. Should be k minus num plus 1. It is so slow. Just answering greater than 3. Okay, maximum will not be 2. Maximum will be k plus 3. K plus 1 actually, because um, if we have already k there, then we have to add elements from 0 to k minus 1 and then k. So total will be k plus 1. By this, okay, yeah, it was not working because the minimum was already less than, because that function will check this also. I think this should work. Internet is quite slow. Come on, work already. Yeah, I knew that. So see that fifth one was much easier than the fourth one for me. So let's think on fourth one. I really don't want to do this question. I think I should write this and it will be much easier. But I don't like writing. I think I should stop here. This is sufficient for today, I feel so. I just don't want more writing. So, bye bye. These were 4 questions. I think I should explain each of them. That was the main motivation of my video, I think. That should be that should be the main motivation of this video. The final one, this next. Yeah, it will like. So in the first question, it was it was very intuitive that we have a array and we have to make it positive and we have to add a value to each element. So if we have to add value to each element, it will be n x of that value. Let's suppose. Let's see, like if we add val to each element, then it will add n into val to the whole array, but we don't want a large positive sum. We just need to make the sum just or just greater or equal to 0. To make that, we need to add the negative sum as a whole to the array. So if this sum got divided into these element, it will give us the right answer. So that was the whole intuition behind it. It was easy, I think. Like most of you will skip this part of the video because I think like it is very intuitive. No offense to people who didn't get the. So here we had to add it was quite easy question. You can see that we if we want minimum x at the end, we just need to add n a 1 each and time. So it will give us n. If we want to maximize, if we want maximum x at the end, we need to add 3 each and time. It will give us 3n. So if m is not in between these two range, then it is not possible to make m. And there is also another catch, that whether you add 1 or 3, it will not change the what it will not change. Okay, it will not change something like change the final parity. The parity will get flipped each of the n time. So we have to make sure that the parity of n or 3n, both will be same, should be equal to m. Or for those who don't know what is parity is, so parity is that the number is even or odd. So this was the whole catch in this question. Let's move to other question. So like the main logic lies in this question in this GCD. So the main, like, what we are doing actually, we are trying to find a D. So how will the D come? So D will be the, like, okay, how, how like you can understand this by, like, you want AI should be equal to AI minus 1 plus some lambda into D, and we want this for all I greater than or equal to 0 and I less than n. This, okay. So to accomplish this, we need the difference between the consecutive element should, like, there should be some way to divide them into the chunk, which will be like a factor of each difference, so that we can just put as many element as we want in between, and it will, like you can, it is like if we have like difference of 3, let's say 1 2 3 between one element, and difference of 6 5 6, yeah. So what we really trying to do, like we will not put any element here, and we will put one element here. Why we are putting one element here? Because we can divide it into two, and after division it is getting into 3. But if you look at the case of, if we have difference of 3 between two element and 2 between so the common difference we can get is 1 only, which will be the GCD, because these are co-primes. These are primes actually, and co-prime as well. So for co-primes it will be 1 only, because we can, you cannot divide it in a way that both will be divisible with the same D. If it would be other than 1, it would be, if it be possible, then GCD of these two number will not be, like these two gaps will not be GCD of these two gaps will tell us that. So this was the main intuition, I will say. And if you move to the max one, so the main observation I looked at is that like how we are going to get k. So we can choose any range, but what will affect our range will be k. Like in the if in that range the k lies, then it will not the max is not possible. Like the max will not be possibly k. So we have to exclude k. Other than k, we can take any element in the array. After taking the elements, after taking these ranges where k do not is not there, we can just add other elements which like from 0 to k minus 1, like just choose the ranges where k is not there, because if k is there, firstly you have to observe that if you have any range where k is not there, you can make that range, the particular range, such that it can be we can insert k in that range. And for every range this is possible, and all the ranges will be independent because of this condition, that if k is there, we cannot uh, possibly get k, so we cannot merge two ranges, and we can extend ranges from one k to another. This condition guarantees that the choose the range where k is not there, because if k is there, there is no way you can get max of range equal to k, because k is already there and max stand for the minimum excluded integer. So we have to just choose the ranges where k is not there, and we can just add the elements from after that. Just add the element from 0 to k minus 1 and which are not already present. If you do so, then there will be like 0 to k minus 1 element, and if you take the max of this range, then it will be definitely k, and you can just insert k in this range. And for each range between 1k to another, we just find this, and this will be our final answer. And and if you think about the array where all the elements are k, like if all the elements are k, you can just choose an element and the max will be 0 and insert it. Choose any k and take max, which will be 0, and change the array in the form of k comma 0 comma k dot 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 or before dot, and it will become the previous question. So it was easy as that. It was just an observation you have to look at, but I didn't like, it was just an intuition. So that's all for this video. I hope you like, I don't hope anything. Bye.